Assistant Professor, Department of SNS College of Technology. In this lecture series video of electric circuit analysis, today's problem or topic is about reciprocity theorem. So problem number 1 in reciprocity theorem. So calculate the Vx through reciprocity theorem by interchanging the position of 12 amp sources and Vx. So we have to find out the Vx value by interchanging the position of 12 amps. So 12 amps current source is located in this path. So interchanging it with an nodal analysis of V2, we are getting the same value by interchanging the source. So in this reciprocity theorem, we have to analyze the node which is relevant to the nodal analysis. So here this is the node 1, node 2 and node 3. So we keep this voltage as a reference voltage which is equal to 0, that is basically grounded. So remaining are the voltage sources. In this whole circuit only one current source is present. Is there any? There is no voltage sources present in this circuit. So this is the 12 amps current sources, the only sources present in the circuit. We are going to keep it in this place and analyze the value of Vx and then interchange this into this 1 ohm resistor, and then we have to analyze the Vx value. So firstly we have to convert it into matrix form. So here 1, 2 and 3 loops are present. So obviously we are getting a 3 cross 3 matrices. So by direct inspection method we are filling this 3 cross 3 matrices. So V1, V2, V3 and the current source is 12 ohm present in the first loop and the remaining 2 loops are as 0. So applying the Cramer's rule for that inspection method, we are getting the delta value as 0.95. So keeping that as 0.95 value as a del value, we are applying the Cramer's rule for the same matrices value. So we can get del 1 is equal to 21.4 and del 2 is equal to 5.05, del 3 is equal to 9.72. So here Vx is identified by using the values of, so Vx we are considering these. So Vx is equal to V2 value. So V2, so the common terms is V2. So V2 we get 5.05. So that is equal to your Vx value. So next step we are going to interchanging the current sources value. So here the first loop 12 ohm resistor is connected across the 1 ohm resistor. So this is your first loop, second loop and third loop. So in this loop arrangement, we are having the current source value is in here. So for this circuit, we are forming the matrices value of 3 cross 3 by using the direct inspection method. We can able to find out the V1, V2, V3 value. Whereas the only change in this formation of matrices is here we are using the current source in the first loop, and then here we are using that in a second loop. So the 12 is interchanged into the second loop. So by applying the Cramer's rule for applying the matrices, so direct inspection method we can get the del value as 0.95, and then applying the Cramer's rule we can get del 1 is equal to 5.05, del 2 is equal to 9.72, del 3 is equal to 3.75. Here we are employing this V2 value is and Vx value is in the first loop. So obviously we can say that Vx value is in your V1 value. So the V1 value we can get 5.05. So that is written as 5.05 volt. Here we have to note that simple thing. In here also we are having the del 2 value is 5.05 and here also we are having value is 5.05. The only differences is in this we are getting it in the second loop, here we are getting it in the first loop. So interchanging the source does not affect the value of the Vx value, but it also gives the same value as like it was solved in the previous loop. So in this we are getting Vx is equal to 0.05 and V2 is equal to 5.05 volt. I want to convey a little thing that if this theorem is known as a reciprocity theorem, as name itself is this connected in a bilateral and linear circuit only. By changing the voltage value or current value, the output, that is a load voltage or a load current, will not change. So this is the specification